So, welcome everybody. My name is Sandro Paganotti, and I'm a client-side developer for The Guardian News and Media. Today, in the next 50 minutes, we are going to talk a bit about the service worker. So, first we're going to introduce about what a service worker actually is and how it works, and then I want to share with you some use cases, because I think this technology is pretty powerful. So, let's start with a very basic HTTP workflow. So what happens is that, of course, when we at the browser display a link, the user, for example, click a link or something, the browser generates an HTTP request. The request goes through the net to the server receives the request, generates the response, and returns the response back to the browser. As a front-end developer, one of the things I always find frustrating is that it's very hard for us to deal and work with, intercepting this kind of request. Because most of the times, for example, if you want to intercept HTTP request leaving your page, maybe the JavaScript, when the JavaScript kicks in, maybe some assets has already been downloaded, and also you don't have that much control on that specific part of your web application. This, of course, is going to change with the service worker. The service worker is basically just a JavaScript file. It's a JavaScript file you can install in your browser, and basically it's going to sit like between the page the user is viewing and the server. So it's not your page, it's something in between. And what happens? Once the service worker has been installed, every time the browser generates an HTTP request that leave from the same origin from which the service worker has been installed, the service worker receives a fetch event containing the request. And then the service worker can choose what to do with that specific request. So it's kind of having a sort of a proxy between your page and the server. And this is super useful because, for example, the service worker can choose to forward the request to the server, like a normal workflow in a normal website. But in same situations, can also choose to maybe look up for a response in a local cache. Let's suppose we have an offline situation, or maybe for some performance reasons we don't want to perform the whole round trip to the server. What we can do is we can check on a local cache if we got something, and then we can return that something to the page. But there is more. By being just a simple JavaScript file, a service worker can also forge a response. And this is super useful. So, for example, in this case, what happens is that this is actually a working service worker, just 3 lines of code. And what it does, it intercepts all the requests coming from the page, and it responds with the generated responses containing the words, sorry, no cats available. So basically, we are intercepting all the requests coming from our origin and returning this forged at runtime response. So service worker, it's like having a new layer between the page the user is viewing and the server. And this opens up a wide range of use cases we're going to explore today. But before beginning, there are some rules we must obey when we are using the service worker, and there are 4 big rules that need to be respected while using the service worker. So the first thing is that the service worker is something that we install, and so it's not available during the first access to our page because it's being installed. So it's going to kick in only after the second access to our page, or when the user browses another page in the same origin. The service worker works only if the origin is under HTTPS. This is for security reason, because basically the service worker is something between something between the page and the server. So all the data we are going to generate is going through the service worker. So to avoid man-in-the-middle issues, the connection must be as protected as possible. That's why HTTPS. The service worker is bound to a specific region, so when we register a service worker, of course, service worker is going to work only for that specific region. We can, if we want, restrict further the scope of a service worker by using a scope option. But, I mean, if we don't, the service worker is going to be bound to that specific region. And the last rule is that we can't have two service workers looking after the same page at the same time. So this can't happen, and we are going to see how the browser is going to handle, you know, procedures like updating a service worker also. But you can't have two service workers working at the same time, intercepting the same request, because it's going to be like messy. So with that said, let's start exploring a few use cases. The most common way to use a service worker and the most common use case is, of course, when dealing with offline access. That's pretty straightforward. We don't have a connection. It's super useful to have this kind of proxy to intercept all the requests and route the request somewhere else locally, probably to a cache or something. So we're going to implement this very easy workflow, which says every time we receive a request, if the request is cached, we're going to return the cached version. Otherwise, if there's an online connectivity, we're going to check and search the request on the server, send the request on the server, and if the server is not available for any reason, we're going to return a fallback page we cached previously. And so notice how we choose our caching strategy. There are a lot of different caching strategies. We picked that one. And one of the features of the service worker we see today is the fact that, you know, by being a simple JavaScript file, we can change and shape the caching strategy to our desire, which is a big advantage. So the code itself, it's pretty simple, just like 20 lines of code. Service worker, as I said, it's something we install. So we have like an install phase. And during the install phase, what we want to do, we want to store locally some of the assets we are going to need, you know, in further request. So what you do here, we use this open method. And this open method is against the cache object. So the cache object is, you know, the browser has already a lot of ways to store things locally. Local storage, IndexedDB, there's also the WebSQL database, which is now deprecated, but it's still there. But none of them were really suited for this job. So what happens is that the browser vendors create a new kind of cache with a new set of cache API. And basically, these cache API are super easy to use because they are just a key value pair. But the interesting thing is that we can use request as keys. So we can basically store the request as a key and the response as a value, and that makes super easy storing, you know, and saving locally response from the server to be used when there's no connectivity. So we open the cache. We need to specify a bucket because we can have multiple buckets. And then, once the cache has been opened, we invoke the add-all method, specifying all the assets we want to store. This operation is during the install phase, and it is non-blocking, I mean, from a user perspective, because the service worker runs in a separate thread, and the user is already browsing the page. This happens like undercover, underneath the cover, under the hood. At the moment, the add-all method is not available, but it can be polyfilled by a library you see we use in the first line of the code. It will be natively supported soon. OK, so now the service worker has been installed, and all the assets we require have been cached. So it's time to implement our strategy. The strategy, of course, we're going to implement the strategy on the fetch event. So every time we receive a request, we want to perform a certain set of actions. In this case, what we want to do is we want to check against the cache if the request has already been cached. And this is like the third line of this code. Then, if the request has been cached, we want to return that response. if the response has been cached, I'm sorry. We want to return that response. Otherwise, we want to perform a fetch. So we want to forward the request to the server and then return the response. In a normal web environment, this part would be handled by an XML HTTP object, which is the usual way we use to do AJAX requests and this kind of thing. But with the service worker comes a new set of API, which can be used also in a normal web page. And this set of API is called the fetch API. Basically, this fetch method you see there, basically is like a new way to perform AJAX request. So it's promise-based, it's easier to use than the old one. It's, like more modern in a way. So we invoke the fetch, passing the request as a parameter. The fetch basically just forward the request to the server, and then two things can happen. The server is actually there, so it generates a response, so our promise gets resolved. We got the online, which is our response, and we return the response. Otherwise, for some reason, the server is not there. It might be offline. We may be offline too. So in that case, what we do is that the promise gets rejected. We intercept the rejection, and we return instead an asset which stored locally during the install phase. This is worth noting that the cache is smart enough to accept also a string as a key, and to go, if you specify a string as a key, the cache is going to look for the request containing that specific file name, which is interesting and handy in this situation. So, but the power of the service worker is that this is code. I don't know if any of you remember the app cache. The app cache was an early attempt to tackle this problem by allowing us to write a text file containing a list of assets we want the browser to download. The problem with the app cache was that the caching strategy was like hard-coded into the feature, into the technology, so we hadn't had the option to change the strategy. With the service worker, it's super easy. So this is a cache-first strategy. Let's suppose we want to do an online first. So we want to first hit the server, and then if the server, for some reason, is not available, we want to search in the cache. It's just a matter of reordering these things. So this is a server-first strategy. We first forward the request to the server, then if we got the response, we just return the response. Otherwise, we are going to search in the cache for the same request, and if we got that response cached, we're going to return the response. Otherwise, we just return the fallback page. So the beauty of this technology is that we can decide our own caching strategy, and it can be as complex as we want. There's a very, very interesting article written by Jake Archibald called The Offline Cookbook, which explores in more details all the available caching strategies. I mean, most of them. Okay, so let's move to something a little more complicated and more interesting, I hope. So, service worker is a process. It's running like in a separate thread while the user is browsing our page, and it receives an event every time the user generates an HTTP request. So let's suppose we want to build like this website, but instead of having the server generating the HTML pages, we want to have the server expose some REST APIs or some JSON-based API. But we still want the user to, explore a fully rendered web page. With the service worker, what we can do is we can use the service worker to compile a template against a JSON response. So, for example, in what we're going to see now is a website that forward all the URL that ends in search something to YouTube, extract the JSON from the YouTube, compile the JSON against a local cached template and generate a page for the user. And at the same time, it stores that page, so the next request is obviously faster. Let's have a quick demo. So, as I said, doing the first access, the service worker needs to be installed. So now the service worker is there, installed, and running. And what happens is, if we now perform, if we now browse to search/something, our query gets redirected to YouTube by the service worker. The JSON gets collected by the service worker and then compiled against a template we already stored locally during the install phase of the service worker. So let's, for example, search for cats. Okay, and this is the result. And the interesting thing is that from a user perspective, from a page perspective, this is a fully rendered HTML page. So if we, for example, try to look at the source code, this is HTML. But we know that we just received the JSON. All the magic happened in the service worker. And of course, if we now try to get the same page, it's even faster, because now it's locally cached. So it's super fast. Let's see how we can achieve this behavior. Let's first have a look at this workflow. So what we're going to do is, if the user is browsing something like search and then a search term, we basically want to check if that page has been already cached. If so, we want to return that page. Otherwise, what we want is that fetch the results from YouTube, compile the result against a locally cached template, and return and cache that response. We also want to do more or less the same for all the JPEG images. So what we want to do is, every time the browser search and try to get an image, we want to check if that image has been cached. If so, we want to return that image. Otherwise, we just go into the server, catch the image, and store the image locally. So this is a template, which is a very simple handlebars template that says iterate over the items and print an image containing the thumbnail and the title. This is the fetch. So the service worker now has to implement a very basic routing mechanism, because now we can receive two different kinds of requests. One is search something, and the other one is something that ends in JPEG, which is, of course, an image. What happens here is that we start creating something which vaguely resembles a routing mechanism, a routing engine. And someone has done, has done more than this. And like 2 days ago, Mozilla has released a fully functional router for the service worker. So you can implement your own routing logic within the fetch. This is like a very early attempt to obtain something like that. And so let's for a moment skip the search things, and let's concentrate on the JPEG, which is easier. So what we're going to do here is, every time every time the service worker receives a request containing for an image, we invoke the getImage function. The getImage function basically do something very close that we saw before. So the getImage function go on the cache, search for the image. If the image is there, return the image because we already cached it. Otherwise, we want to fetch the image from the server, and we want to return the image and store the image locally. This is another slightly different caching strategy, if you think, because now we are not storing anything up front, but as soon as the user requires an image, we're going to store it, which is another way of caching things. Just a note. In theory, using the normal Ajax API, we wouldn't be able to access an image from an external origin. I mean, if the image itself does not expose the coarse headers. because you can't access different regions from an Ajax request. But in this case, the fetch API implements this nice mode, which is mode no course, that basically tells the browser, okay, but I don't want really to manipulate that asset. Just download it for me and give me the response. I'm not going to manipulate the response. I'm going to just return the response to the browser. So this is a nice way we can use to access also assets that are not on on the same origin as the page. Then we got the response, and then we invoke store response. Store response is a function which basically do two things. Store the response on the cache, which is done in the first 2 lines of code, in the second and the third line of code, and return the response to the page. The only thing to note here is that we don't want to wait for the cache to finish storing the image, because we don't want to have to add additional loading time for the user. So we don't want to wait for that promise to be resolved. We simply invoke the two things one after the other. The service worker runs on a separate thread, so we can return the response, and then the service worker will keep storing, will keep running until the cache has been, the image has been added to the cache. Yeah, this is too much code, but it's the biggest slide. You're not going to see more code than this on this presentation. So what happens here? This is the function that we use to compile the template. So when the user writes something like search / the search term, what we want to do here is we first go to our local cache. We extract list.hbs, which is the file we saw the first 3 slides ago, which is the template. We get the template. From the template, this might sound strange, but the body of the response itself must be extracted using an asynchronous method. So this is why you see extract the list, get the template, and then template.text, because we need to ask for the body of the response, which is another asynchronous method. Then we get the body, we perform another fetch. This time we are going to YouTube to retrieve the JSON. When we got the JSON, we extract the JSON using res.json, and finally we have both the JSON and the body. The body we got locally from the cache, and the JSON we got remotely from YouTube. Now it's just a matter of compiling, and we can use underbars. Underbars can be required using the import script function on the top of the file, and then it's just a matter of following the underbars API. So we can compile the file, and then we can generate a response containing the generated HTML generated from the template and the JSON file. Finally, we can use the same store response function to cache and return this generated HTML. So this is, another way to use the service worker, not only for caching things, but also to perform this kind of template compilation. This is an interesting way of maybe building a website which does not need to send HTML across the net every time, but it can use locally stored templates. Oh yeah, I forgot. It's fine. So before moving on to another few use cases, we need to first address the issue about how we can update a service worker. So suppose we have a running service worker, and we want to, as a developers, we want to, update the service worker the user already have installed. So every time a page tries to register a service worker, the browser checks online if a new if a new version of the same service worker is available. If so, the browser downloads the new version of the service worker, but at that point, the old service worker is still running. And it's working because it's serving the page the user is currently browsing. So what happens is that the new service worker receives the install event, And so the service worker, the new service worker can, for example, set up his own cache or perform some boot procedures, something like that. But then the new service worker is like placed in a suspended state, so it's not active until all the pages that depend on the old service worker have been closed by the user. So the users need to manually close all the tabs that are relying on the old service worker. At that point, the new service worker receives a new kind of event, which is called the activate event. The new service worker can use to basically update the old database or retrieve information from the old database or from the old cache in order to, like migrate the old information into the new format. After the activation event, basically the old service worker gets dismissed and all the subsequent requests are going to pass through the new service worker. So this is how the browser handles the ability to allow us to update the service worker. Okay, a few more examples, a few more interesting use cases. Suppose you have like a web server that that you don't control, like a remote server, that expose a very nice set of API, but they talk just in XML. So you can't really do anything about that on a server side because you don't control the server. And then suppose you are using on your client application, you're using like a JavaScript framework, which works very well in JSON, but doesn't understand XML. So you have basically the only option you have before a service worker was like trying to patch the framework in order to allow the framework to understand XML. Now what you can do is you can use the service worker to transparently convert XML to JSON. So from a framework perspective, your framework will see actual JSON while the server will expose XML. Let's have a short demo of this. I don't know if any of you have always played to EVE Online. EVE Online is a multiplayer online game, and EVE Online has a very nice set of API, but some of them are still in XML, like this one. So what happens here is you're seeing a very simple application that basically is just performing an AJAX request to the remote API, and it's just printing the result on the screen. So this is what the API are returning now. But at the same time, this application has now installed a service worker. And so if we refresh the page, we are going to see a JSON now, because the service worker has kicked in, has intercepted the request, and instead of returning the XML, has converted the XML into JSON. And now we are able to read the JSON and extract, for example, the number of players we have online at the moment. We can... OK. So to create this demo, one of the biggest issues I had to face was the fact that, like every XML parsing library on the client side, rely upon the window object, because they use like a DOM parser object, which is an object very useful to parse like XML or HTML. The fact is that the service worker is not a page. So the service worker doesn't have the window object. You can't access the window object from the service worker. So the problem is to find a library which is able to parse XML without relying on DOM parser, which would be very difficult. If not, JavaScript has already a very interesting community of developers that face the same problem on the server using Node.js. So what we can do here is we can rely upon a Node.js library instead of a JavaScript library. We can use NPM to install the library, and then we can use Browserify, which is a nice command line tool, to basically work around the problem of the modules which are handled differently on the server than on the client. Browserify takes our library and generates a single file we can include in our service worker, and then we are able to parse XML. We can use the same concept also with images, which is super nice. So now you can see on one side a JPEG 60K, and on the other side a BPG. Even if we are on a projector, you may see that the JPEG is very less detailed than the BPG. But the size is the same. So the BPG is a better format than the JPEG. The problem is that no browser at the moment implement a BPG decoder, so there's no way you can send a BPG to the browser. But what we can do is we can use the service worker to convert under the hood a BPG image into PNG. So we can use, the same level of detail without wasting additional space by having a service worker and doing the conversion at runtime. So here's the demo. Okay. So the first access is from, yeah, there's no image here. I don't know why. But. So the first access is from the actual PNG image, because what happens is that, of course, during the first access, the service worker is not yet installed. So what we see here is the PNG image. But now, if we reload the page, you're going to notice that the page itself is like receiving the same PNG file, but in fact, what we transmitted over the network is the BPG file. The service worker got the BPG file and translated into PNG. So we use the service worker as a transforming machine to transform BPG in PNG to save, bandwidth and to get a more detailed result on the page. Okay. The only problem with this solution is that it's quite CPU intensive. You are basically encoding a new image in the browser, so on the device. But surprisingly, the most expensive bit of this procedure is not decoding the BPG image, which is pretty cheap, but it's encoding the BPG image, the PNG image. So what I will do in the future is try to experiment with other formats, like encoding in BMP or in JPEG or something else, to see if the encoding mechanism on those formats is less intensive than this one. And plus, there's also a nice talks going on the What2G mailing list to migrate some of the Canvas functionalities into the service worker. That would be awesome, because the Canvas has a very nice method called toData_URL, which allows us to extract a PNG image out of a set of bitmap data, which would be awesome, because in that situation you don't even need to encode a PNG via JavaScript. You could invoke a native function. Okay. The most interesting probably part of the service worker is that service worker is not just something we can use to cache things or to intercept requests. It's like having a proper engine we can install in the browser that can do a lot of different things. One of the other very interesting features of the service worker is the ability to receive push notification from a server. These push notifications are going to look exactly the same as native push notification on mobile devices. They can even work even if the user has closed the browser. So we can send a push notification to a mobile device, and even if the user has already stopped using your website or your application and has already closed the browser, he's going to receive the notification the same. The same that happens with the native apps. There are few, this is quite an experimental, still an experimental feature. So there are a few like extra constraints we need to worry about if we want to implement this on our website or on our app. The first one is that we need to have at the moment the only messaging server and allowed to that's allowed by the browser is the Google Cloud Messaging server. This is not, of course, what we're going to be in the future. We're going to have like a plurality of different servers because they are working on like a standard protocol. But at the moment, the Google Cloud Messaging is the only one we can use. And the other thing we have to care about is that we need to provide the manifest.json file alongside to our HTML file, and so that contains a few information the browser is going to need. This also is as a standard that will be implemented soon by all the browsers and everything, but at the moment it's only useful to enable push notification. So let's have a demo. So the first thing we notice now is that when we open a page that includes push notification, the user receives like an explicit message that asks him, okay, this website wants to send you push notification. Do you agree? Do you allow or you disallow? In this case, we want to allow. What happens next is that this application, the demo I created, generate and print for us a curl request to the messaging server we can use to test the actual push notification capabilities. In a practical scenario, these curl requests should be made like by our server, so in a server to cloud messaging environment, but we'll see that later. So I allow this. Yeah, I got this curl. Okay, and if everything works, now I paste the curl. Yeah, this always happens. I tried it like 2 minutes ago. Let's try one more time. This can be everything because we are relying on the network. So, okay. Yeah, here we are. So now we got the push notification, and these push notifications are super useful because even if we have the browser like minified or on mobile, if our browser is closed, we gotta see this notification the same. So it's like a new way to reach our user even if they are not actively browsing our page. Let's see how this works in. Oh, now I can close this. Okay, so this is our page. In a complete environment, we got our server and the Google Cloud Messaging server. So the first thing is that as soon as the user reached our page in the browser, he got the message we saw before that says the website wants to send you push notification. Do you allow or not? Let's suppose we allow. What we can do then is we can register against the Google Cloud Messaging server and get back two important information. One is the endpoint we need to ping, and the other one is the registration ID, which basically identified this specific page, this specific user. Now, what we want to do is we want to send these two information to our server, because at that point, our server will then be able to ping the Google messaging server with these two information, and when the Google Cloud Messaging server will receive this ping, will then in return ping the service worker which has been installed in our page. That will result in the notification. It's important to say that the last part is not compulsory. So what happens is that every time the the device receive a push notification, the service worker receive a push event. And then it's up to us to decide what we want to do with that push event. So we can show a notification, but maybe we can also, store something into the local database or ping back our server or do something else. It's up to us. We just receive the ping from the server, from the Google Cloud Messaging server. Which brings me to the last use case. I don't know if any one of you has already heard about the physical web. Physical web, it's basically a project by Google. It's more like an experimental project to give an URL to physical objects, like a plant or a chair, something else. So how we do this? This is a beacon. It's a very small Bluetooth broadcaster that basically simply broadcasts a URL. At the moment, you need an application, but in the future, your device will be able to pick up this broadcast and show you like a list of the URLs broadcasted around you. So you will be able to interact with them by just following the URL. So this is a very interesting scenario because we can like mix the power of the beacon with a service worker to get like the ability to subscribe to a physical object. So let's suppose we have like a plant or something. We can get close to a plant with a phone. The plant has a beacon, so it broadcasts a URL. You can like click on the URL from your device. The URL goes to a page that installs a service worker. And then you are subscribed to the plant. So you can walk away, and maybe after like 2 hours, the plant can send you a push notification telling, I need water, or something like that. So I've tried to come up with another example on these things, and this is how it works. So you have the beacon broadcasts the URL can be cached by a device, and then if the user navigates to the URL, you can install a service worker. Then, as we saw before, our server can use Google Cloud Messaging server to send a push notification to the service worker and then to inform the user about something. Let's have another scenario on this case. Let's suppose we have, like at a bank office, and there are this queuing mechanisms where you have to go pick a ticket, like a physical one, and then wait for your turn, this kind of thing. So we can reinvent this behavior, this procedure, using a service worker and this kind of technology. It's too hard to have a live demo of this. So what I did, I recorded a video, and I will walk you through the video. Okay. So first of all, let's have a look at the setup. There's a phone here. There's a smartwatch here, paired with the phone. Here we have the beacon, at the lower edge of the screen, and in the background you see a laptop. The laptop is showing the manager interface, so the interface we use to say, okay, I want to serve the next customer, and the customer is using the device. So the first things that happens is that the customer is going to see the URL broadcasted by the beacon. So the customer is going to see, like in this case, NoQ, which is the name of the application. The customer can then tap on the notification, and that opens the page which contains the application itself. That says, hi, do you want to subscribe to this specific queue? And the customer can say, yes, I want to subscribe. Then he got the message from the browser saying, do you want to allow this application to send you push notification? And the customer say, yeah, I allow that. So, okay. And then the customer, what the customer can now do is close the browser and walk away. So we can just, we try to close the browser, we close the browser, and we walk away. Now, from a manager perspective, let's say I'm ready to serve the customer. So from the manager interface, you're going to see like a mouse pointer. I'm going to click next. And what happens is that we are going to receive a notification on the device, on the far left corner of the device, and on the smartwatch the same. So what happens now is that the user has received this notification even if he's away, and he can interact with the notification, in this case from the device. And as you can see, the notification is looking exactly the same as a normal native notification. He can tap on the notification, and then he gets back to the application, which says, "Hurrah, it's your turn. Go to the desk because we want to serve you." Okay, that's not all. Service Worker has a lot of more features to come in the future. I want just to list two of them, which are really interesting. The first one is the ability to schedule background tasks. So we will be able in the future to ask the Service Worker, ask the browser to wake up our Service Worker after a certain amount of time, periodically. So each 2 hours, let's say. This is especially useful if we want to like update our offline content. So the user can always see like the latest news or something like that. And the other interesting feature is geofencing, or geofencing, I don't know. So geofencing is the ability we are going to have to ask the browser to wake up our Service Worker if the user enters or exits a specific area. So we can receive a notification. I mean, the Service Worker will be invoked if, for example, the user is close to a church or a monument or something else. We can choose whatever we want. Now, the problems. First of all, the Service Worker is a very experimental technology. At the moment, Service Worker is supported in production, so I mean, on a stable release only by Chrome. Firefox is working on it, and it's, I mean, in a good position. Some of the features are already in the native build. We don't know about Microsoft, Safari. We don't know. The good news is that, on, for example, on Android devices, basically Service Worker is working out of the box. So if we are targeting Android devices, we can already use it. And also all the Chrome browsers already implement this feature. The other bad news is that at the moment it's really hard to find out a nice way to test the Service Worker. So you can test the single components of the Service Worker, but the whole, the whole thing, it's kind of complicated to test. So this is still something I'm working on. And the last thing is that at the moment, I mean, it's better than like a few months ago, but still there aren't that much guidelines or articles or tutorials on Service Worker. That's it. Thank you. This is the URL of the presentation, but I think it's going to be shared also by the conference. And if you have any questions, I'm here. Yep.
So you mentioned earlier the no cross-site request thing. How do you make sure that that doesn't fetch the wrong kind of information that the cross-site policy was supposed to prevent?
No. You can basically with the fetch, what you can do is you can actually fetch something which is in theory not allowed by the cross-domain policy. So let's suppose you are, let's forget for a moment about the Service Worker. Let's suppose you are in a browser, okay? If in a browser you generate a page which contains an image, which source is not the same source as the origin of the page, that works. Because the browser, I mean, can download an image from a source which is not the source of the page. What you can do is access the image or access the data to manipulate it. The fetch provides you a similar mechanism using the no-course mode. Basically, it returns you the response, but the response is so-called opaque. that means you can't access the response. You can just return the response to the page in order, the page to be able to consume the response, but you can't really do anything with the response. So you can just get it and give it to the page. You can't manipulate it. For example, let's suppose it's an MP3 file. You can't open the MP3 file and perform some kind of data manipulation on the MP3 file if it's coming from a different domain. You can just pick the MP3 file and move it to the page, send it to the page. Yeah.
So how is performing in mobile?
Well, the service worker is basically, this is something I forgot to say, but you may have seen it from the code. Service worker is 99% asynchronous. It doesn't support anything that includes synchronous access to data. For example, from the service worker, you can't access local storage because it's a synchronous API, but you can access IndexedDB because it's asynchronous. So the service worker is optimized for battery savings and to be very, very wise in terms of computational. I mean, it's something that runs even if the user is not browsing the page, but the browser has control over it. So it should be really, really wise in terms of performances and battery save. That's the idea. This means that basically the browser is going to wake up the service worker only when required. You can, for example, have a user browsing your page, and because the user and the page is not requiring any HTTP request, the service worker is sleeping. It's going to wake up as soon as the page generates an HTTP request. So it's kind of super energy saver technology.
Is it easy to set the expiration time?
Of the service worker itself. In terms of, if you're speaking about the for how long the service worker can run, this is up to the browser. So it's not something you can control directly. But, I mean, of course, the service worker will try to run the minimal amount of time required to complete your task. So it's also up to you to have a very performant task on the service worker. This is kind of a, like a compromise.
If I cache one request,
Mm-hmm.
for how long it's going to be there?
Oh, the cache itself is going to be permanent, so you need to manually delete the request from the cache. So the cache itself, as soon as you put something in the cache, it stays there. You need to access the cache and remove it. Yeah?
Service workers could be used for the following use case. So instead of calling directly a database or a REST service, just update locally the data in an offline mode and let the service worker perform some kind of replication server.
Yeah, in theory that would be possible. So what you just said is that it would be possible for having a service worker that interact with the database, with a remote database or remote set of API, download them and store them locally, right? That generates some kind of replication, local replicate database. And that's part of the service worker capability. So, for example, on the install phase, you can perform just that. You can access the database, download everything, open a local IndexedDB, which is a database you can open locally, and store the data on your local IndexedDB, which is a way.
But I mean also the other action. Let the user perform this action on the local storage
Mm-hmm.
and let the service workers push the data to the server.
Mm-hmm. Okay. Okay, yeah, that would be possible. I mean, at the moment, it's already possible, but it will be like complicated to some sense because the last one. Okay, because what you can do is you can't activate a service worker from the page because the service worker life cycle is controlled by the browser. So you would have to generate a fake HTTP request to trigger the service worker to perform the sync. But what you can do in the future the mailing list, the What Would You mailing list, is already start talking about the sync event. So with the sync event, you could do exactly that. So you'll be able to like have the service worker run locally while the page is not working, performing this kind of syncing operation. So it's definitely something on the radar.
Okay, one more question. The service worker is still available? Is it available on your browser?
In our view. Yeah, and of course only on Android, but yes. Yes. Okay, thank you.